So far, we have discussed two different ways to solve systems of equations. First, by substitution, where you take the equivalent of a variable and you replace the variable with that and then solve. And sometimes when we look at a system of equations, that is obviously what we should do. If you look at this, we already have y by itself, so we can take this y down here and replace it with 2x minus 11 and solve the system of equations. We also talked about elimination, and this system of equations is clearly set up for elimination because we can just add those equations together, eliminate the x's, and get 3y equals 6, so y is obviously equal to 2. However, there are some times we come across a system of equations where it's not so obvious. If you take a look at this, we don't have a variable by itself, so it's not obviously a substitution problem, but also we don't have any equal but opposite coefficients on either of our variables. Even if they were exactly equal, we could just subtract. So either way, this is not set up ideally for a elimination method. However, there's a couple things that we can remember. We can multiply or divide everything in an equation by the same number and still get an equivalent equation. I was just at the hardware store this morning buying nuts and bolts, and if I double the number of nuts and bolts that I buy, I'm going to double the cost that I have to pay at the register, but that does not affect the price for each individual item. So if you have an equation where the price of nuts is N and the price of bolts is B, the value of N and B does not change based on how many of each we get, but the equation will look a little different. What I mean is we can take this first equation and say, well, I'm just going to multiply everything in this equation by 3. And you might be wondering, why in the world would you do that? Well, 2x times 3 is 6x, 3y times 3 is 9y, and 15 times 3 is 45. Now, take a look. The y's will cancel each other out. I get 9x equals 63, so x equals 7. And I can take that and plug it back into one of my original equations and figure out what y is from there. That's kind of nice to do when you have fractions also. Like if you take a look at this system of equations here, I've got 3 halves and negative 3. If I just multiply everything in this equation by 2, I would get 2x plus 3y equals 7.5 times 2, I think, is 15. The y's cancel out. We get 3x's equals 21. I know how to do basic math. All right, so let's take a look at the cool down. So Lynn and Priya were working on solving this system of equations. Lynn's first move is to multiply the first equation by 3. Priya's first move is to multiply the second equation by 2. Those are both valid moves, right? Because we get equivalent equations. Now, number 2 here, though. Whose first move would you choose to do to solve the system? Explain your reasoning. Which person is more likely to get an easy system of equations that they can either add or subtract together to solve the system? That's really the question. If you need any help, make sure you talk to me, talk to your teacher, whoever that is, and have a great day, I guess.